We're going to review solving two-step equations. Two-step equations are the equations where you have to not only add or subtract with your inverse operations, but also multiply or divide with your inverse operations. Our first example is going to be 2x plus 3 equals 13. So in this example, our variable is currently being multiplied by 2. So that's going to let us know that here's one inverse operation that we're going to have to perform. We also have a plus 3, so this tells us we have a second inverse operation that we're going to need to perform, equals 13. So we want to isolate our variable, and currently our variable is with a 2. So the first step is actually going to be to isolate the 2x by using an inverse operation on the plus 3. So we want to isolate this 2x. And so by doing that, we need to have 2x on the left-hand side of parentheses by itself. So we're going to use an inverse operation. If we're plus 3, then we need to subtract 3. And as a rule, what we do to one side of the equation, we have to do to the other side. So I need to subtract 3 from both sides. So now, if we look, we have plus 3 minus 3. This is going to give us 0, and 2x plus 0 is 2x. So in essence, instead of writing 2x plus 0 and then writing the 2x again, we're just going to, in our minds, say this cancels out, leaving us with 2x. 13 minus 3 is 10. So now we're left with our second inverse operation, our second step of the two-step equation. We have x being multiplied by 2. To undo multiplication, we have to divide. Since we are multiplying the variable by 2, we want to divide by a 2. And remember, as a rule, what you do to one side, you must do to the other side. So I'm going to divide by 2. All right, 2, if we look now, 2x divided by 2 is going to give us 1x. When we write 1x, we can just write x. We don't have to include the coefficient of 1. So instead of including that coefficient of 1, we can say in our minds, well, 2 divided by 2 cancels out, and we're left with x equals, and then 10 divided by 2 is 5. So what we have is that x equals 5. Remember that you do want to check your work. I'm not going to check all of these examples, but I do want to show you how you check your work so that you can do that on your own. So to check your work, you plug the value you found for your variable into the original equation, which was 2x plus 3 equals 13. So 2 times 5 plus 3, 2 times 5 is 10, plus 3, and 10 plus 3 is 13. That does in fact equal 13, so our check has proved that x equals 5 is a solution to this equation. All right, let's work with some negatives. If I have 2x plus a negative 3 equals 13, all right, so now we have to remember that we can rewrite this just to show 2x minus 3 equals 13, because that's what we have here. Remember, when we have plus a negative, we are subtracting. So that tells us that when we go to do our inverse operation, we need to add 3 to both sides. For 2x equals 16, then we divide both sides by 2, x is equal to 8. Let's do another example using some negatives. 2x minus a negative 3 equals 19. Okay? In this example, we have minus a negative. So when we go to use our inverse operation, we want to be very careful because we need to remember that minus a negative is the same thing as saying plus. So what we really have here is 2x plus 3 equals 19. And again, we want to subtract 3 from both sides. So we isolate that 2x. 19 minus 3 is 16. Now we divide both sides by 2, so we can isolate the x. And x is equal to 8. All right, let's look at an example where we need to simplify first before we start our steps to solving the equation. X plus 7 minus 3x plus 3 minus 5 is equal to 15. Now, if you notice, now on the left-hand side of your equation, this is one really long expression with 1, 2, 3, 4, 5 different terms. So what we're going to want to do to work with this is simplify by combining like terms. Okay, simplify by combining like terms. So I have x and minus 3x are like terms because they both have the variable x. And then our 7 plus 3 and minus 5 are like terms. So now if I say x minus 3x, I'm going to get minus 2x. And 7 plus 3 is 10, minus 5 is a positive 5. So plus 5 equals 15. Now I'm ready to start my two-step solving this equation using my inverse operations. I want to isolate my negative 2x, so I need to use inverse operation on this plus 5 so that the negative 2x is isolated. So since I'm adding to undo addition, I subtract. And that's going to leave me with negative 2x equals 10. And now I'm ready to divide. Now, what's different about this one is now we're saying our variable x times a negative 2, which means to undo this multiplication, I need to divide both sides by negative 2. Not just 2, but negative 2, because negative 2 is the coefficient. And so that's what we need to divide by, negative 2. Negative 2 divided by negative 2 is a positive 1. So that's going to cancel out and give us x equals, and 10 divided by negative 2 is going to give us a negative 5. Okay. All right, let's look at our last example. And I do encourage you to pause the video. Try to work out the example first. And then unpause it and check your work against the video. All right? So this time we're going to have to not only simplify like terms, but we're first going to have to use the distributive property so that we can simplify our information that's in the parentheses. Okay? So what we have here is we have negative 3 times the difference of 3 times x minus 2 minus 4 times the sum of 2x plus 6. This equals negative 52. Now if you remember that the signs that we see in front of the numbers, whether they're plus signs or minus signs, let us know something about the number. So the fact that this is minus 4 tells me that I'm going to be multiplying by a negative 4. So